Continuing with our discussion of functions in Module 1.1, here we're given the equation of a function and asked to evaluate in a couple different examples, starting with example number 4 that asks us to evaluate the function g at the input or x value of -9. That's how I read question number 4, g of -9. And all that means is I go back to the function called g in my instructions and replace the input variable by -9. That's what I've done here. Instead of x over 12 minus 3 over 16, I've got -9 over 12 minus 3 over 16. So I've input -9 in place of x. From there, I'm just going to do the math of reducing 9 over 12 to 3 over 4, so that now I've got -3 over 4 minus 3 over 16. And then to subtract fractions, I need a common denominator, which in this case will be 16. Then I've got -12 over 16 minus 3 over 16, and then I combine the numerators and keep the common denominator for -15 over 16. That's my output when I input -9. That is when my x value is -4, my output or y value is -15 over 16. Question number 5 is similar. We're given an input value and asked to find an output value, but here note in question, as opposed to question number 4, question number 4 asked us to input -9. What we've got in question number 5 is -g of 9, which is asking us to input +9 and then make that output negative. And here's how I'm going to show that using my notation. What's inside the parentheses here is g of 9. I went back to the function g and plugged in 9 for x. That's 9 over 12 minus 3 over 16. And then using parentheses, I'm going to say, take that whole result and make it negative for -g of 9. All right, so let's work what's inside the parentheses first, reducing 9 over 12 to 3 over 4, much like we did in question number 4. Reducing that fraction, to subtract fractions, we need a common denominator. So I have 12 over 16 minus 3 over 16. This time, 12 minus 3 is 9 over 16. And finally, having reduced what's in the parentheses, now finally I'm going to apply the negative that was outside the parentheses and change that 9 over 16 to -9 over 16. And that's my output from -g of 9. And notice questions numbers 4 and 5 have different results. You get different results if you plug in a -9, like in question number 4, versus plugging in a +9 and then applying a negative afterward, which is the difference between the two there. Finally, in question number 6, we're looking at we still have g of x, we still have a value of 9, but this is something quite different. In numbers 4 and 5, we were given an input value, we were given an x value, and we were finding the corresponding y value, the output value. This time, we are not given an x value, but we're told what the function is equal to. The whole function is equal to 9. The difference here, and it's an important one to note, is that we are given the output. It's like we're given the answer, and we have to go back and find the input. We're given the output, and we have to go back and find the input. And what we're asked for here is what. So one way to read this g of x equals 9 is we're trying to find the x value that is going to eventually give us an output of 9. And how do we do that? How do we find what x value gives us an output of 9? Well, we set g of x equal to 9. What is g of x? It's x over 12 minus 3 over 16. So we're setting g of x equal to 9, and we're asking what input value x will give me a result of 9. And this is the math that we need to do, solving this equation and figuring out what x is. And we've done that in Module R. We've reviewed that, where we've solved equations involving fractions. And my suggestion was the easiest way to do that is to clear the fractions by finding an LCD. Between 12 and 16, the LCD ends up being 48. And when I multiply both sides by 48, 12 goes into 48 4 times, 6 goes into 48 3 times. Doing the math here, multiplying both sides by 48, I end up with 4x minus 9 equals a relatively large number, but that's okay, 432. From here, I simply add 9 and divide by 4. Add 9 to both sides to cancel that minus 9. 4x equals 441, and then divide by 4 to cancel the 4 coefficient, and I get x equals 441 over 4. So there, and there's no way I could have figured out that number 441 over 4 without doing all the math here. But this tells me I need to, if I want an output of 9, I need to input 441 over 4. And see the difference between the two types of problems here, where you're given an input and asked to find an output, like in questions 4 and 5, versus where you're given an output and you have to work back and figure out the input, like in question 6.